Hello class, Miss Amami here. Today we are going to have our second lesson from a probability unit. In the previous lesson we learned about probability. We also learned how to calculate experimental probability. It means that we conducted some probability experiments and then calculated the probability. In today's lesson we are going to focus on theoretical probability. It means that we are not going to actually perform the experiments to collect data. We are going to calculate the probability using math theory. So one more time, let's go over the definition. So what is a probability? It's the likelihood of an event happening. We want to estimate how probable it is for a certain event to happen if the same experiment is repeated. Now this time we are focusing on theoretical probability, and probability of event A happening is number of successful outcomes. So when we do an experiment, how many of the outcomes are the ones that we are looking to happen over how many possible outcomes we have. And this will become more clear when we do some examples. The first example we are going to do is an example with rolling a die, and we are talking about a six-sided die. In a six-sided die there are six possibilities. You can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6, and all of them have the same chance when you roll your die. Now a six-sided die is rolled. What is the probability of part A, rolling a 5? Now event A is rolling a 5. Probability of A is total number of outcomes. When you roll a six-sided die, there are 6 possible outcomes, and 5 is one of them. So the probability is 1 divided by 6, which is 16 points, approximately 16.7%. Now part B, what is the probability of rolling an odd number? So we call this event B. Rolling an odd number. So probability of B, again, when we roll a die there are 6 possible outcomes. How many of them are odd? When we get a 1 and a 3 and a 5. So 3 of them are considered odd numbers. So you have 50% chance of, which is 0.5 that you multiplied by 100 to get the percent. So 50% chance of getting an odd number. Now a number greater than 2. So the possible outcomes, I'm going to write them here, are 1, 2, 3, 4, 5, 6. So this is event C. Probability of C is, again, we have 6 possible outcomes. How many of them are more than 2? 1, 2, 3, 4. Either you get a 3 or a 4 or a 5 or a 6. So 4 out of 6 which is 0.667, which is approximately 66.7%. Now, what is the probability of number which is not 6? So we will call this event D. Again, we have 6 possible cases. How many of them are not 6? 1, 2, 3, 4, 5. So 5 of the outcomes are not 6. .833, which is 83.3%. Now, the last one is, the last example is asking for a probability of rolling a 7. Now, we have 6 possible outcomes. None of them are 7. You can never roll a 7 on a 6-sided die. So there are 0 outcomes that meet this condition, which will 0 divided by 6, which is 0, which is 0%. That means there is no chance, and that is true. There is no chance to get a 7 on a 6-sided die. Now, let's move to another example. This one is marbles from a jar. A glass jar contains 6 red, 5 green, 8 blue, and 3 yellow marbles. If a single marble is chosen at random from the jar, what is the probability of choosing a red marble? Now, the question is, how many is the total number of marbles? We have 6 plus 5 plus 8 plus 3, which is 20. Now, this is the total number of marbles in a jar. Now, if we want to choose a red, event A, the total number of marbles is 22. And when you put your hand inside the jar, there are 6 red ones. So 6 out of 22 is the possibility or the probability of getting a red one. So we do 6 divided by 22, 27.3. So 273, which is 27.3%. Now, choosing a marble which is not red. So the probability of event B is, out of 22, the ones that are not red is the green, so we have 5 options there, blue, 8 options there, and 3 yellow. So it's going to be 16 out of 22, 72.7. Now, the last one is choosing a red or a yellow marble. So, probability of event C. We have 22 marbles in total. 6 are red and 3 are yellow, which is going to be 9 out of 22. 0.409, which is 40.9%. Now, another probability experiment is when you pick a card from a standard deck. So before we do an example about choosing a card from a standard deck, I want to review how a standard deck looks like. So in a standard deck of cards, you have 52 cards. We have 4 suits, we have spades, we have hearts, we have diamonds, and we have clubs. So there are 4 different suits. As you can see, spades and clubs are black, hearts and diamonds are red. Now in each suit you have 13 cards, which is ace, which looks like this, and it counts sort of. In some games it has a big value, but in some other games it counts as 1. And then you will have 2, and then you will have 3, and all the way 4 and 5, and you go all the way 6, 7, 8, and then all the way the 9. I can't find the 9 right now. 10. But then you have what we have called, so this is 10 cards which have numbers on them. But then we have what we call face cards. We have jack, we have queen, and we have king. These 3 are called face cards because they actually have a face on them. So if you think about it, each suit has 13 cards. Ace to 10, which ace you can look at it as a 1, and then we have jack, queen, and king. So let's keep that in mind when we do our next example. So if one card is drawn from a standard deck of cards, find the probability of drawing a club. So this is event A, probability of A equals. We have in total 52 cards. How many of them are club? The ones that are in club are 13. 1 to 10, and then the 3 face cards. So 13 over 52, which is 0.25, which is 25%. Now, what is a probability of drawing a red card? We have, that is event B, we have 52 cards. The red cards are hearts and diamonds. We have 13 hearts and we have 13 diamonds. So 26 divided by 52, which is 50%. And half the deck is red. So you should have been able to guess that. Now, what is the probability of drawing a face card? Each suit has 3 face cards. So we have 3 that belongs to hearts, plus 3 that belongs to diamonds, plus 3 face cards that belongs to spades, and we have 3 that belongs to clubs. So in total we have 12 face cards. So it's going to be 0.231 approximately, which is 23.1%. 12 divided by 52. Now we are going to continue in with our examples with deck of cards. So again, if one card is drawn from a standard deck of cards, find the probability of drawing not an ace. We have 52 cards, 4 of them are ace. So you will do 52 minus 4. So 48 are not ace. Are other things, are other numbers and face cards. So 58 divided by 52, 0.923, or approximately 92.3%. Now, a red face card. So again, we have 52 cards. Now we have 3 face cards that belong to hearts: king, queen, and jack of hearts. We also have 3 red cards that are face cards that are diamond. So 6 of the face cards are red. So it's going to be 6 over 52. 11.5. Now, what is the probability of drawing a heart, a club, a spade, or a diamond? Probability of C is, we have 52 cards in total, 13 of them are heart, or a club, 13 of them, or spade, or diamond, which is 52 over 52, which is 1, which is the same as 100%. And it makes sense. If you draw a card from a deck of cards, it's one of these. 100% is going to be one of these suits. There isn't anything else that you can draw from. That's why you get this number 100% here. Now, we are going to move on to a little bit more complicated examples. Sometimes when you do theoretical probability, it's not very straightforward just to do it by calculating the desirable outcomes over the total number of outcomes. And in those cases, it's helpful if you want to use a chart or a tree diagram to help with finding some probability. So let's do some example here and see how we can do that. Now this time, instead of working with 1 die, we are working with 2 dice. And please remember, when it's a single word, is die. When you have more than 1, the plural is dice. Okay? So please keep that in mind. So the game is, you roll 2 dice, okay, at the same time, and then you add the numbers. And there are many games board games that you've played, and that's how it is. So for example, in this case, your sum will be 10. Or in this case, it's going to be 6. Now, it is very difficult to figure out all the possibilities of what's the first roll, what is the second roll. So in this case, it will be much easier if we create a chart to help us with this problem. So I'm going to roll this up here. Okay. And I am going to create a chart like this. So we have 2 dice. The possibilities on die 1 is you can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. The same thing on your second die, you can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. So these are all the possibilities. Now, if the first one is 1 and the second one is 1, it is this scenario. So when you get 1 on both of them, when you add them, you're getting a 2. The first one is 1, the second one is 2. 1 and 2, you get a 3. First one is 1, the second one is 3. 1 and 3, 4. The first one is 1, the second one is 4. So you get a 5. First one is 1, second one is 5, you get a 6. First one is 1, the second one is 6, your total will be 7. Now, you also have a possibility to get a 2 on the first one and 1 on the second one. So that's gonna give you a 3. And we have to keep completing this chart. A 2 and a 2 will give you a 4. A 2 and a 3 will give you a 5. A 2 and a 4 will give you 6. 2 and a 5 will give you 7. 2 and a 6 will give you 8. 3 and 1 will give you 4. 3 and 2, 5. 3 and 3, 6. 3 and 4, 7. 3 and 5, 8, and 3 and 6, 9. First die can be 1, the second one can be 4, and the second one can be 1. So 5, 6, 7, 8, 9, 10. 5 and 1, 6, 7, 8, 9, 10, 11, and then 7, 8, 9, 10, 11, 12. So we create this chart, and now we start with the first example. First of all, how many possibilities we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 1, 2, 3, 4, 5, 6. So total possibilities is 36 outcomes we have with 2 dice. Now, rolling a 7, probability of A equals. How many times we can get a 7? You have to look at these ones. 1, 2, 3, 4, 5, 6. So out of 36 possibility, 6 times we get a 7. 6 divided by 36, 0.167, approximately 16.7%. B, what is the probability of rolling a total less than 8? Again, we have 36 cases. Now, how many we have less than 8? So, everything here is less than 8. So, we count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 of these outcomes will give you a sum less than 8. So 21 divided by 36, 58.3. Rolling doubles. Doubles means when both dice have the same number on it. Like 1 and 1 is a double, or a 2 and 2 is a double, or 3 and 3 is a double. Now we have 1 and 1, which is this one, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. So 6 out of 36 are doubles. 0.167 approximately, which is 16.7%. Rolling a total of 13. The highest you can roll is actually 12. So there is no possibility, zero outcome, that you have a total of 13 out of 36. That means 0, which is 0%. No chance. No chance of rolling a 13. The highest you can roll is 12. Now, rolling a total of 1. The same thing here. The lowest you can roll is you roll 2 ones and you get a 2. So again, 0 out of 36, which is 0 or 0%. The last example that we are going today is an example where we can see how we can use tree diagrams to help us with doing some probability questions. A couple would like to have 3 children. Create a tree diagram to help you with this problem. We want to figure out what is the probability of having different combination of boys and girls for this family. So they have a first child. They can get a boy, or they can get a girl. It's a 50-50 chance. Now, they can have a boy, and then when the second child comes, they can have a boy and then another boy, or they can have a boy and the second child is a girl, so they can have a boy or a boy girl. Or their first child is a girl and then they can have a boy as a second child, or they can have a girl. So they can have a girl boy or girl girl. Now it's time for the third child. Again, they can have a boy, and the third child a boy, or a boy, and then after the second child they get a girl. They can have a boy, a girl, and then another boy, or boy, girl, another girl. They can have a girl, a boy, and a boy, or a girl, boy, and a girl. And then they can have girl, girl, and then end up with a boy, or girl, girl, and a girl. Now, for these kinds of example, it's very helpful that you write all the possibilities. It is very helpful if you write all the possibilities here at the side. So the first option is they can have a boy, boy, boy. So I'm going to write boy, boy, boy. Or they can have boy, boy, and a girl. So they can have a boy, boy, and a girl. They can have a boy, a girl, and a boy. So boy, girl, boy. Or boy, girl, girl. Boy, girl, girl. Then they can have girl, boy, boy. Or girl, boy, girl. They can have girl, girl, boy. And they can have girl, girl, girl. So in total, if you have 3 children, 2, 3, 4, 5, 6, 7, 8, there are 8 possibility of combination of the boys and girls. Now we can focus on calculating all these probabilities. So the first one is probability of 2 girls and a boy. So probability of A equals, there are 8 total possibility. How many of them are 2 girls and 1 boy? That's 1. 2 girls and 1 boy. So 1, which is boy, girl, girl. There is also this one, girl, boy, girl. So 2 girl and a boy. So that's 2. And then the first 2 are girl followed by a boy. So 3. So 3 divided by 8 is 37.5%. So they want to have 2 girls and a boy. So the first one can be boy followed by 2 girls, or it can be a girl, then the middle child is a boy, then a girl, or they can have 2 girls and then followed by 1 boy. Now, what is the probability of having no girls? Out of 8, the only choice where there is no girl is when they have 3 boys. So 1 of them. In all the other one, there is at least 1 girl. So 1. So it's going to be 1 divided by 8. 12.5%. One or more girl. So there is no girl here, so we don't count this. There is 1. There is 1. There are 2, 1, 1, 2, and 3. So 7 out of 8 cases, there is 1 or more girl. So that's 87.5%. And then what is the probability of having all boys? It's this case, boy, boy, boy. In all of the other cases, there is at least 1 girl. So probability of D is 1 out of 8 is all boys, which is 12.5%. As you can see, B and D are the same probability, because having all boys in other words is the same as having no girls. So as you can see, in problems like this, it is going to be much easier if you use a tree diagram, so you can figure out what are all the possibilities. Stay safe. Have a good day. Goodbye.